So today I'm going to talk about plane wave solution, or in other words I can say that the free particle solution of the Dirac equation. So as discussed in the earlier lecture that alpha, I and beta, they are matrices and their order is 4 by 4, right? They are the matrices of 4 by 4 order, and if they operate over psi, that means psi must be a column matrix, right, such that the psi, it can be written as, this is psi 1, psi 2 RT, psi 3 RT and psi 4 RT. So it must have 4 rows and 1 column, so it's a column matrix. Now for the motion of an electron, electron under no external force, Dirac boldly suggested that relativistic equation to be solved is means for a free particle, because no external force is acting for such a free particle, so this equation must be solved. So let me write down this equation: C alpha dot P plus beta m naught c square psi is equal to E psi, and let me call this as equation number 1 and this is equation number 2. So this equation is, because it's a matrix, right? Psi is a matrix, so that means this equation is equivalent to 4 simultaneous first order partial differential equations that are linear and homogeneous, in 4 psis, because we are having 4 values of psi. So the plane wave solution of the form that is psi is equal to u e raised to power iota pr minus et over h cross, right? So this is the plane wave solution, and here the space, it contains space and it contains time, so that means exponential term enters through exponential term we have entered the space and time dependence. So that means the space and time dependence enters through exponential factors. through exponential factor, and in matrix representation of alpha, beta, E and P behaves like complex numbers. So let alphas and beta operate on one column matrix. And U means alpha and beta, they operate over U, means this is a column matrix, and we call this as this U as a spinor, right? So if I use this equation number 3 in equation number 2, then that means using 3 into what we are getting, that C alpha dot P plus beta m naught C square, it is U e raised to power iota PR minus ET over H cross, and this must be equal to EU e raised to power iota PR minus ET into H cross. So this part will cancel out and we will remain with the equation, that is C alpha P plus beta m naught C square, it's U must be equal to EU. So let me call this as equation number 4. Now for the sake of convenience, let us assume that electron is moving in that direction. So if electron is moving in z direction, then that alpha dot P, it can be written as alpha z pz, or you can write down it as pz alpha z. So if I put value of this, then it is 0 sigma z and 0. It's a polymatrix, sigma is a poly. So I can write down it pz 0 0 0, it is 1 0 0 minus 1 0 0, sorry, not 0, but it is 1 0 0 minus 1 0 0 0. So if I write down it like this, then I can say that it is 0 0 pz 0 0 0, it is 0 minus pz, it is pz, it is 0, it is 0, it is 0, it is 0 minus pz 0 and 0. That's what we are getting. And similarly I can calculate beta m naught C square. So it is m naught C square, the value of beta will be I 0 0 minus I. So if I put their values, it is 1 0 0 1 0 0 0 0 0 0 0 minus 1 0 0 minus 1, and it is m naught C square. So if I put its value, then it can be written as that m naught c square 0 0 0 0 m naught c square 0 0 0 0 minus m naught c square 0 0 0 minus m naught c square. I can write down it in this way, right? So now using these values in equation number 4, so using these values, that alpha dot p, equation number 4 means alpha dot p is, sorry, it is equation number 4, so that it is c alpha dot p minus beta m naught c square. Its u is equal to u, so that means I will put their values, these values, this value, this is basically alpha dot p, it is its value, and beta m naught c square, its value will be this. If I put these two here, then I can write down that it is c 0 0 pz 0 0 0 0 minus pz 0 0 0 0 minus pz 0 0, right? These are the values which I have substituted, plus m naught c square, m naught c square 0 0 0 0 m naught c square 0 0 0 0 minus m naught c square, then 0 0 0 minus m naught c square, right? u1 u2 u3 u4, and it is equal to eu1 u2 u3 and u4. So let us club these two matrices. So if I club these two, then I can write down it as because this u is sitting just like this, right? So it is like this. Let me this is like this, right? And then u1 u2 u3 u4 then let me club these two matrices. So I can write down m naught c square, it is m naught c square 0 cpz 0 0 m naught c square 0 minus cpz, it is cpz 0 minus m naught c square, then 0 0 minus cpz, it is 0 and it is minus m naught c square. That's what I am getting. And here it is u1 u2 u3 u4, right? And it's equal to EU1, EU2, EU3, EU4. So that means this leads to the equation. This leads to 4 equations. That is let me call this as equation number 5. And this is equivalent to m naught c square u1 plus 0 plus cpz u3 plus 0 is equal to EU1, and 0 plus m naught c square u2 plus 0 minus cpz u4, it is equal to EU2 cpz u1 plus 0 minus m naught c square u3 plus 0 is equal to EU3, and 0 minus CPZ U2 plus 0 minus M naught C square U4 is equal to EU4, right? So let me do little more algebra here and bringing this towards this side. So I can write down M naught C square minus E U1 plus 0 plus CPZ U3 plus 0 is equal to 0, and it is 0 plus M naught C square minus E U2 plus 0 minus CPZ U4 is equal to 0, and here it is CPZ U1 plus 0 minus M naught C square plus E U3 plus 0 is equal to 0. It is 0 minus CPZ U2 plus 0 minus M naught C square plus E U4 is equal to 0, and let me call this as equation number 6, and this is very important. So let me call this as equation 6.1, 6.2, 6.3 and 6.4, right? And I will use these equations in later on, and in the matrix form I can write down this as that it is M naught C square minus E 0 CPZ 0 0 M naught C square minus E, it is 0, it is minus CPZ, it is CPZ 0 minus M naught C square plus E into 0, then it is 0 minus CPZ 0 M naught C square plus E, and it is U1 U2 U3 and U4, it's equal to 0. So now let us do little more algebra, little mathematics to make it more simple. So let us choose that M naught C square minus E is equal to A, M naught C square plus E, it is equal to A prime, and CPZ is equal to B. So if I use these values in this, then this will become, this is this we have chosen this to make it more simple, right? So that means this our equation will become, means our matrix A0 B0 0A 0 minus B, it is B 0 A prime 0 0 minus B 0 A prime, it is U1 U2 U3 U4, that's equal to 0, right? So now for non-trivial solution of these four simultaneous equations, means for non-trivial solution of these four simultaneous equations, the determinant of the coefficients of U1 U2 U3 and U4 must vanish, right? That is, I can say that the determinant A0, B0, 0, A 0 minus B, then B0, A prime 0, 0 minus B0, A prime, its determinant must be equal to 0. So let us solve this determinant, right? So let me expand it through this. So it is A determinant of A0 minus B, right? Then 0 A prime 0, then minus B 0 A prime, then again expanding through this because for these two will be 0, so it is plus B. So I can write down it as 0 A 0 B 0 A 0 minus B, then minus B 0 A prime, and this must be equal to 0. And let us simplify it again. So it is A here expanding through this, so it is A prime 0 0 A prime, right? That's what we are getting. Then expanding through this, for this it is negative and it is positive, so it is plus minus B, it is 0 A prime minus B 0, then for this it is B, so if I will expand it through this, then it is minus of A, and it is B 0 0 A then it is plus minus B, it is B 0 0 minus B, it is equal to 0. And if I expand this, then it is minus B, it is 0 plus B A prime. So I have simplified it, so it is equal to, means this is equivalent to A prime square minus B square A prime plus B, it is minus A prime B plus B cube, right? And it is equal to 0, means its expansion will be this, and this whole expansion will be equivalent to this one. Then let me do little more algebra here. A square A prime square minus B square A prime plus A prime, sorry, it is minus, not plus, but because plus minus will become minus, so it is B square plus B4, plus B4 is equal to 0, which implies A prime its square minus twice of A prime B square, putting these two together, plus B4 is equal to 0. That means this is A prime plus B, sorry, not plus, but it is minus B square, its whole square is equal to 0. Now let me put their values. So if I put their values, then I can say that m naught c square minus e, it is its value, and its value will be minus m naught c square plus e, right? But then minus b square minus cpz whole square, and whole square, it's equal to 0. So now you understand and why I have chosen these A and A prime and B. This is just for the sake of simplicity. So, and it is, if I take this minus common, then it is A minus B and A plus B. So I can write down it as m naught c square whole square minus e square and this minus is outside, and cpz square, so it is c square cpz square, and I can take whole square is equal to 0, or it will become positive, and it will become minus negative. So it is minus m naught square c4 plus e square minus c square pz square whole square, it will be equal to 0. So in other words, I can say that e square minus m naught square c4 plus c square pz square is equal to, right? So that means this is the square. So separately I can say that this is e square minus m naught square c4 plus c square pz square is equal to 0. This is the mathematical interpretation, means each factor must be equal to 0 and both are identical. M naught square c4 plus c square pz square is also equal to 0. So from these two, because both are identical, so this leads to the fact that e square is equal to m naught square c4 plus c square pz square, right? Now I can write down that e is equal to plus minus m naught square c4 plus c square pz square raised to power 1 by 2. Thus we are having two solutions. So let me interpret this solution. So that means e plus minus, it is equal to plus minus m naught square c4 plus c square pz square raised to power 1 by 2, and each occurring 2 times, because we must have 4 values, right? We must have 4 values, so each must occur 2 times, each root. So that means this is e plus, and I can write down m naught square c4 plus c square pz square 1 by 2, and this occurring 2 times. Similarly, I can write down e minus, it is minus m naught square c4 plus c square pz square raised to power 1 by 2, and it is also occurring 2 times. This is the main thing which we have to keep in mind. So now let us go back to the equation number 6. Let us go to the equation number 6. So they are occurring 2 times. So now again consider equation number 6. So if I consider that equation number 6, and let me write down that here. So m naught c square minus e u1 plus 0 plus cpz u3 plus 0, and it is 0 plus m naught c square minus e u2 plus 0 minus cpz u4 is equal to 0. Here it is cpz u1 plus 0 minus m naught c square plus e u3 plus 0 is equal to 0. 0 minus cpz u2 plus 0 minus m naught c square plus e u4 is equal to 0. It is equation 6.1, and it is 6.2, and this is 6.3, and this is 6.4. Let me call this whole as equation number 6, as I talked about it earlier. Now there are 2 possible solutions. So for e is equal to, e plus is equal to m naught square c4 plus c square pz square under the root, because this is the positive solution. And if I consider that particle at rest, if I consider here particle at rest, that means pz is equal to 0. So if I put it here, then I can say that E plus is equal to plus m naught c square. From this equation I am getting this. And if I put value of E is equal to E plus m naught c square, then these two equations will vanish, right? These two equations will vanish, means 6.1 and 6.2 will vanish, because in place of E we are putting E plus and which is equal to m naught c square. So this will be 0 and this will be 0. So this makes that these two equations will vanish. So now from equation 6.3 it will become cpz u1, because this will not vanish, plus 0 u2 minus m naught c square plus E plus and u3 plus 0 u4 is equal to 0. That means that cpz u1 is equal to m naught c square plus E plus and u3 is equal to 0, which implies that u3 can be written as cpz m naught c square. So for any arbitrary solution, let u1 is equal to 1, then u3 can be written as cpz m naught c square plus E plus, right? So therefore we are having the solution for this is that u1 is equal to 1, u2 must be equal to 0, u3 is equal to cpz m naught c square plus E plus and u4 is equal to 0. So this is the solution which we are getting, and if I put these values, that this equation 6.3 will be satisfied. So for 3 this was the solution. And similarly for 6.4 equation, from 6.4 and I can say that if I take this equation, then from this equation that cpz u2 must be equal to negative of m naught c square plus E plus, it is plus, right? So it is E plus u4. So from here I can calculate that u4 must be equal to, u4 is equal to minus cpz over m naught c square plus E plus u2, and for u2 is equal to 1, I can say that u4 is equal to minus cpz m naught c square plus E plus, right? So thus we are having the solution of this form, that u1 is equal to 0, u2 is equal to 1, u3 is equal to 0, and u4 is equal to minus cpz up over m naught c square plus E plus. That's what I'm getting here, right? So now for next part, means for E minus equal to m naught square c4 plus c square pz square raised to power 1 by 2, and for pz is equal to 0 as we treated in the earlier case, that E minus is equal to minus m naught c square So therefore for E is equal to E minus, and which is equal to minus m naught c square, equation 6.3 and 6.4 will vanish, and let me consider equation 6.1. So if I consider equation 6.1, then from that m naught c square minus E minus u1 plus 0 u2 plus cpz u3 plus 0 u4 is equal to 0. So from here I can calculate that u1 is equal to minus cpz over m naught c square minus E minus and u3, and for u3 is equal to 1, I can say that u1 is equal to minus cpz m naught c square minus E minus. So therefore u1 is equal to minus cpz over m naught c square minus E minus, comma u2 is equal to 0, u3 is equal to 1 and u4 is equal to 0. This is the arbitrary solution for this 6.1. Now let me consider equation 6.2. So if I consider equation 6.2, then I am getting that is 0 u1 plus m naught c square minus E minus u2 0 u3 minus cpz u4 is equal to 0. So therefore m naught c square minus E minus u2 is equal to cpz u4. So from here I can write down that u2 must be equal to cpz over m naught c square minus E minus u4. So therefore I can write down for u4 is equal to 1. So if I take that u4 is equal to 1, then for this I must have 4 values, that is u2 is cpz m naught c square minus E minus. So therefore we are having arbitrary solution for this, that u1 is equal to 0, u2 is equal to cpz over m naught c square minus E minus, u3 is equal to 0 and u4 is equal to 1. This is the solution which we are getting. So thus 4 linear independent solutions are there. I sum up these all, right? So thus we have 4 independent solutions, that is u1 1 0 cpz over m naught c square plus E1. This is from equation number 6.3, and this is u2, this is from 6.3, sorry 6.4, and it is 0 1 0 minus cpz over m naught c square plus E plus, right? So this is from 6.3, this is from equation 6.4, and here we have chosen that E plus is m naught c square, and here E plus we have chosen as m naught c square. And similarly u3 we are getting it as minus cpz over m naught c square minus e minus, it is 0 1 0, and u4 we are getting 0 cpz over m naught c square minus e minus, it is 0, it is 1, and this is from 6.1 equation and this is from 6.2 equation, and here we have chosen that e minus is equal to m naught c square and e minus is equal to minus m naught c square, right? So for these we are getting this, and these are known as the solutions, independent solutions. Now let me go to the limiting case. So if we take a limiting case, in the limiting case of the particular particle at rest, now for the limiting case, that is particle at rest, that is pz is equal to 0. So that means if in these equations we will put pz is equal to 0, then u1, u2 and u3 and u4 can be written as, so let me try to write down these values. So it is yeah, so that means energy corresponds to, we are having either this solution m naught c square, and other solutions are m naught as I discussed in the earlier slide, and it is minus m naught c square. So for this we are getting u1, it is 1 0 0 0, right, and here it is u2, it is 0 1 0 0, and for here u3 is equal to 0 0 1 0 and u4 is equal to 0 0 0 1. These are the solutions which we are getting, and we call this is for the spin up, this is for the spin down, and this is for the up spin, and this is for the down spin. So now if we define a spin matrix, such that sigma z prime is equal to sigma z 0 0 sigma z, means 1 0 0 minus 1 0 0 0 0 0 0 0 0 1 0 0 minus 1, right? So we have to use this here. So sigma z is this one, and let me yeah, right, and if I use this spin matrix, then we can find, if we do little algebra, then if we apply sigma z prime, u1 is equal to, we are getting u1, and sigma z prime u3 is equal to u3, that's what we are getting. Means these spinors describe state of electron with z component, and S1 and S3 of spin in positive direction. Yes, it is a positive direction, positive spin, right? This is the positive spin and these are the negative spin, right? this corresponds to S1, this corresponds to S3, and this is S2 and this is S2, sorry, S4. I will talk about it later. So in the positive direction, with plus 1 eigen value, and similarly, so sigma z u2 is equal to minus u2, and sigma z prime u4 is equal to minus u4. So thus, if we operate this with this, we are getting a negative, means negative eigenvalue, means it defines S2 and S4 with negative spin, that is with eigenvalue minus 1, right? So thus this is the solution which we had talked about, and when we do like this, then spin automatically incorporated, right? And another thing which we are getting negative values of energy. So I will talk about that in the next lecture, and this is all about this lecture, right?